Okay guys, welcome back to the channel. I hope you're all doing exceptionally well today. Today we will be looking at our second proof on the specification, and that is proof by exhaustion. Now, if you didn't see my first video, we did a quick introduction to proof by deduction, so we can nice and neatly cross that off now. If you haven't seen the video, I'll put the link in the description, and up in the top corner by here it should pop up. But anyway, we shall just jump straight on into it. Alright, so proof by exhaustion. I'd argue is probably the easiest type of proof that you'll have to do at A level. It's really nice and simple, very straightforward, just only 2 steps to follow. Okay, and so we shall start with our definition. Okay, so again, very much like deduction, we are using something to determine the validity of a statement. And this time, it's using allowable values. Okay, now that sounds a little bit confusing because with deduction, we had to do it algebraically. But for exhaustion, we will be given parameters. And now this is a big caveat here. I'm going to stick this in red warnings. Now, it's very important to remember this because, for example, if you go back and look at my deduction video, the question there, we could have used different examples to do that. However, it said for all even numbers. Now, there are an infinite amount of numbers, as you know. So it's a bit unreasonable to use exhaustion there. You could obviously use 10 examples or 20 or however many, but still, there might be a value much further down the number line that won't agree with the proof. Okay, so this is why we only use this with small number of values, and it's very obvious in the question. So I'll just write our example question now. And our question for today is prove that if integer n is between 1 and 5 inclusive, then n squared minus n plus 11 is always prime. Right, now you could do this by deduction, but obviously it'd be a little bit long-winded and there's not much point because they've given us a set of parameters. Now you might see this written like okay, and that is just your inequality sign. Sometimes it's written like that, sometimes it's written like this. But either way, if they give you parameters in the question, you must use exhaustion, otherwise you'll just be wasting your time. And this just means n greater than or equal to 1 and n less than or equal to 5. So for our first step, all we have to do is sub in and work through. And it really is as simple as it sounds. All we have to do is substitute in the values between 1 and 5 inclusive into this expression here. And if all the values are prime, then we've proven it. Simple as that. So let's just work through this very quickly. And as you can see, all our values are prime numbers, and like our proof question has stated, we must prove that if all the integer values between 1 and 5 inclusive are prime when subbed into this formula, we've proven that it is correct. Okay. And now again, just like proof by deduction, very, very important final step, and that is to rewrite the initial statement. Like I said in the previous video, this is very, very important because this is where you will get your final mark. Okay? So hence, if all the results are prime, then our statement is true. And that's all we need to write. And there you have it, guys. That's as simple as proof by exhaustion gets. I mean, you can't really get much more complicated than this proof. It's a really nice couple of easy marks. So just make sure you absolutely 100% know what you're doing when you go into this type of question. Spot if there is a parameter. Spot what sort of expression you have to use. And also what sort of result we're looking for. Okay? And I'll just highlight that here as well. Breaking it down into the nice sizable chunks is always the best way to approach proof questions, because there's often a lot of information here and it's just nice and easy once you understand what you've got to do. Okay, and we shall conclude our proof videos with disproof by counterexample next time. So all the best and see you soon. Bye bye.